Steel grit is a vital abrasive in surface preparation. Choosing the correct hardness for steel grit is very important for any blasting project. This critical choice significantly impacts how well the surface is ultimately cleaned. It also plays a large role in determining the final texture or profile of the blasted surface. A proper selection ensures the foundation for subsequent coatings or treatments is optimal. The hardness influences the entire process, affecting both the quality of the work and the economics of the operation. Therefore, understanding grit hardness is fundamental for achieving desired results. The right hardness ensures that blasting operations are efficient and effective. It helps to achieve a delicate balance between rapid cleaning speed and the overall lifespan of the abrasive grit. Using the wrong hardness level can unfortunately lead to several operational problems. These issues might include excessively slow work progress, resulting in higher labor costs and project delays. Conversely, an incorrect choice could cause potential damage to the delicate surfaces of the parts being treated, especially on softer materials. This makes careful selection paramount for quality and cost control. This informative essay will thoroughly explore the concept of steel grit hardness. We will discuss the different types of steel grit that are commonly available in the market. These primary types are designated as GP, GL, and GH grits, each with unique properties. Understanding the distinct characteristics of each type helps professionals make much better, more informed blasting decisions. These decisions will be tailored for their specific applications and desired surface outcomes. This knowledge is key to optimizing any abrasive blasting process. We will also take a closer look at the Rockwell C scale, often abbreviated as HRC. This widely recognized scale is the standard method used to measure the hardness of metallic materials, including steel grit. Knowing the HRC value of a grit helps in selecting the most suitable abrasive for specific jobs and workpiece materials. It ensures optimal performance during the blasting process. Furthermore, it contributes to better cost-effectiveness through efficient abrasive consumption and improved consistency in all your blasting operations. The Rockwell C scale, frequently denoted as HRC, serves as a standard industry measure for hardness. It is extensively used to accurately determine the indentation hardness of steel and other similarly hard materials. On this particular scale, higher HRC numbers clearly mean that the steel is considerably harder and more resistant to deformation. Conversely, lower HRC numbers indicate that the steel is softer and generally more ductile in its nature. This scale is absolutely crucial for selecting the appropriate steel grit for any given blasting task effectively and reliably. The hardness of steel grit is a property that is very carefully controlled during its complex manufacturing process. Different hardness levels are intentionally created by heat treatment and tempering to cater to a wide variety of blasting tasks and diverse surface requirements. The specific HRC value of the grit directly relates to how it will perform during the actual blasting operation. It fundamentally affects how aggressively the grit cleans the target surface. Importantly, it also influences how long the grit itself will last before it breaks down into smaller, less effective particles or dust. Harder steel grit particles are generally much more aggressive in their cleaning action. They possess the capability to remove stubborn contaminants, such as heavy rust layers or thick mill scale, quite rapidly and efficiently. However, it is also true that very hard grit, while cleaning quickly, can sometimes break down or shatter at a faster rate upon impact. Softer grit, on the other hand, is inherently less aggressive in its approach, but may offer a longer operational lifespan due to its toughness. It can also produce a smoother, less angular surface finish on the workpiece. The three main classifications of steel grit based on hardness are GP, GL, and GH. Each of these distinct types has a specific HRC range associated with its production and resultant physical properties. This designated HRC range fundamentally defines its working characteristics, such as its cutting speed and breakdown rate. It also determines its suitability for different applications, from light cleaning to aggressive surface profiling. Gaining an understanding of these types and their HRC values is key to achieving effective and efficient blasting results. GP steel grit is an abbreviation for general purpose grit, a very common and widely utilized choice in many industries. It typically exhibits a hardness that falls within the range of 40 to 53 on the Rockwell C scale, HRC. This type of grit is characteristically angular when it is new and unused, providing sharp cutting edges. A key feature of GP grit is its ability to maintain its angular shape reasonably well during the rigors of repeated blasting operations. This consistent angularity makes it a highly versatile choice for a broad spectrum of cleaning applications. GP grit is well regarded for providing a good practical balance between effective cleaning speed and overall abrasive durability. It is very often employed for the descaling of various metal surfaces to remove rust, old paint, or other surface impurities. It also performs well on unfinished castings and forgings, cleaning them and preparing them for further processing. Many diverse industries rely on GP grit for surface preparation work just before the application of new paint systems or protective coatings. It is generally considered a cost-effective option for numerous standard tasks. GL steel grit is often described in the industry as long-life grit, primarily due to its specific wear characteristics during use. It usually has a hardness that is somewhat higher than GP grit, typically falling in the range of approximately 3 to 60 HRC. Although it starts harder, a distinguishing feature of GL grit is that its sharp, angular edges tend to round off more readily during the impact of the use cycle within the blasting machine. This gradual rounding creates a unique operating mix composed of both angular and rounded particles over time in the machine. GL grit is specifically engineered to offer an extended operational lifespan. It is also designed to produce a less aggressive surface etch when compared directly to the much harder GH grit. It is quite suitable for tasks such as descaling and general surface preparation where a very sharp profile is not required. It is frequently chosen when a smoother final surface finish is desired or specified for the workpiece. The gradual rounding effect of the GL grit particles also helps to reduce the abrasive wear on critical blasting equipment components like nozzles, hoses, and wheel blades, potentially lowering maintenance costs. GEH steel grit carries the designation hard, signifying its extreme hardness characteristics compared to other steel abrasives. This particular type represents the hardest category of steel grit commonly available for demanding industrial blasting purposes. Its hardness value is typically measured to be above 60 HRC on the Rockwell C scale. More specifically, it often falls within the range of 60 to 66 HRC, making it exceptionally rigid. GH grit particles are designed to remain exceptionally angular throughout their entire operational life cycle, thereby strongly resisting any tendency to round off during blasting. Due to its extreme hardness and retained angularity, GH grit provides a very fast and highly aggressive cleaning action on most surfaces. It is particularly excellent for the rapid removal of very thick, tenacious scale, such as that found on hot-rolled steel or other extremely tough surface contaminants. Furthermore, GH grit is frequently utilized for etching the surfaces of very hard steel alloys or components that have undergone case hardening. This deep etching process effectively prepares these hard surfaces to achieve strong, durable bonds with specialized coatings such as thermal spray applications or robust industrial paints. When selecting steel grit for a specific task, it is crucial to first consider the desired surface profile or anchor pattern needed for subsequent processes. Harder grits, like GH, will invariably create deeper and sharper profiles on the blasted surface, which can be beneficial for thick coatings. Conversely, softer grits, like GL, that develop rounded particles in the operating mix tend to produce much smoother surface finishes. The type of material being blasted is also a very important factor. Hard workpiece materials may necessitate the use of GH grit. You must evaluate other factors such as the required cleaning speed, the type of blasting equipment being used, air blast or wheel blast, and the overall cost implications. GH grit cleans very quickly but may also wear down faster and put more operational stress on the blasting equipment components. GP grit often offers a good, reliable compromise between speed, finish, and cost for many common applications. GL grit can provide a longer abrasive life with a more moderate finish. If you are ever unsure about the best choice, it is always best practice to conduct tests with small batches of different grits on sample pieces. Crucially, consult with reputable steel grit manufacturers for their expert advice and recommendations tailored to your specific needs and equipment. Keep on searching, guys, and see you on next video.